This is example 4 of multiple integral. We are going to evaluate xy over the region R, where R is enclosed between y equal half x, y equal square root of x equal to 2, and x equal to 4. The first step of solving this problem is how does this R look like? So we need to sketch R. Let's use Desmos to sketch the region R. First, we enter the equation y equal to 0.5 times x. This is a straight line. You can see that when x equal to 0, y equal to 0. When x equal to 1, y equal to half. When x equal to 2, y equal to 1. This is a straight line. Next, we're going to add another curve. Y equal to square root of x. Y equal to x power 0.5. This is a blue curve. You can see that when x equal to 0, y equal to 0. When x equal to 4, y equal to 2. When x equal to 1, y is equal to 1. Next, we're going to add a straight line, x equal to 2. X equal to 2. So this is a vertical line. And next, we're going to add a straight line, x equal to 4. Okay, so we have got the region R, which is bounded by these 4 curves, 1 vertical line, 2 vertical line, and a curve and a straight line. I have integrated region R by yellow color as shown. Now, the second step is to interpret what is dA here. dA could be dy dx, or dA could be dx dy. Which one do you choose? It may affect how easy or how difficult is your integration. First, we must recognize the region we have. This is a type 1 region. Type 1 region is enclosed by 2 vertical lines, x equal to a and x equal to b. So for this case, we have x equal to 2 and x equal to 4. These 2 vertical lines enclose the region. Then the easiest way to do integral of this type is use dA equal to dy dx. And then you find the limit of x first, then of y. I'll explain this later, but this is type 1 region. So your dA is equal to dy dx. Therefore, for step 2, we find out that dA in this case is equal to dy dx, as it is a type 1 region. After we replace dA by dy dx, the third step is fill in the outer limit for x. In this case, x is between 2 to 4. You can see from the diagram, our x value is from 2 to 4. Alright, because the yellow region are the x value is between 2 to 4. Next, we will find the inner limit for y. To do so, you fix a value of x anywhere between 2 to 4. Let's say I fix the value of x at 3. Now this is arbitrary. You can put the value of x anywhere between 2 and 4. So now you draw a vertical line. Now this vertical line go upwards until it first hit at this point. This is y equal to half x. So the lower limit of y is y equal to half x. And if you continue, you pass through the yellow region and hit another point at the boundary. This is y equal to square root of x. So the limit, upper limit for this is y equal to square root of x. So I am going to rewrite the integral x from 2 to 4, then y from half x to y equal to square root of x, integrate xy dy dx. Now you can check your limit whether this is correct or not. You can put the limit, let's say x from 2.5. You can find that if you draw the line upwards, you hit the lower limit at y equal to half x again. And if you continue to draw upwards, you hit the outside upper boundary at y equals square root x again. So it's consistent as long as you keep the x between 2 and 4. Step number 4. Treat x as a constant. Do inner integral first with respect to dy. What does it mean? The inner integral is this portion. Y is a variable. X is fixed constant now. So when you integrate the inner integral, you'll get this is x from 2 to 4 and then you keep x a constant, integrate with respect to y, you get x times y squared over 2, where y equal to half x, to y equal to square root of x, then dx. So this is the inner integral. Put in the limit, then you get x from 2 to 4, and then x times square root of x square over 2 minus x times y, which is equal to half of x square over 2. You can simplify and then you'll get the inner integral. Now, the fifth step is to do the outer integral with respect to dx. We find that the inner integral after simplifying is x squared over 2 minus 1 over 8 x cubed. Now, if we integrate this with respect to x, you'll get x power 3 over 6 minus x power 4 over 32 from x equal to 2 to x equal to 4. After you substitute the limit, you get the answer 11 over 6, which is also equal to 1.833.